In Chapter 1, we learned that a linear function could be written in the form f of x equals a number times x plus another number. Now in Chapter 1 we used the form mx plus b. Now what we're doing is switching basically to ax plus b, where a is taking the place of the slope and b is still the y-intercept. Now we're going to consider a class of functions called quadratic functions. And these can be written as f of x equals a number a times x squared plus a number b times x plus a number c. Now in this case a cannot be 0, or else we have 0 times x squared. That term disappears and we're back to a linear function, something like bx plus c. Now quadratic functions form what is called a parabola. This type of graph has a shape that looks similar to like a mountain, either right side up or upside down, depending on whether it has a maximum or a high point if the parabola opens downward. So that would be like the peak of a mountain, or a low point if the parabola opens upward. That would be like the bottom of a bowl, or if you take a mountain and turn it so that the peak is at the bottom. The xy point, where the maximum or minimum value is located, is called the vertex. The parabola is a symmetric graph, or a mirror image, if you fold it along a vertical line that goes through this vertex point. Now the vertical line is called the axis of the parabola. So let's look at some examples. In the first example, we define y equal to x squared. So in this case, we're letting a be 1, and then b and c are both 0. So there's 0 times x plus 0 for the constant. So this forms a parabola, which is drawn by making a few points and then drawing a smooth curve through those points. So if you plug -2 in, -2 times -2 is 4. For -1, if you square that, you get 1. 0 squared is 0. And then 1, 2, and 3 squared are 1, 4, and 9. Now if we sketch the graph out, you can see that the vertex, which in this case is a minimum value, or the lowest point that the parabola goes through, is the origin 0, 0. The axis actually turns out to be x equals 0, which is the vertical line going through x equal to 0, which is the y-axis. Now let's go on to another example. So in this case, we have y equal -2x squared plus 4. So in this case, the leading coefficient on the square term is -2. There's no linear component, so the bx term with b equal to 0 is dropped out of the equation, and then plus 4. So the constant is 4. What that constant is going to do is shift that curve up 4 units. Now if a is negative, as it is in this case, the parabola is actually going to open downward. There's going to be a maximum value, but not a minimum value. Now how wide or narrow the parabola is going to depend on the magnitude of that leading coefficient on the x squared term. If it's a large number, bigger than 1, then what's going to happen is it's going to grow a lot faster than the y equals x squared parabola we first looked at. So it's going to actually be skinnier if you look at it side to side. If a is a fraction, okay, between 0 and 1, and remember we're just talking about the magnitude of the number at this point, then it's actually going to be wider. It's going to grow more slowly as you move away from the vertex point, or the axis of symmetry. And c, again, simply shifts the parabola either up if c is positive or down if c is negative. So in this case, since I've got -2, I expect the parabola to be skinny and open downward, but shifted up 4 units. So again, we can plug some values in. Okay, so remember our equation. So -2 times, and then plug the x component in, -2 squared. So that's -2 times 4. So that's -8. -8 plus 4 is negative 4. If I plug negative 1 in, I get negative 2 times the quantity negative 1 squared, so negative 2 times 1, or negative 2 plus 4, gives me 2. At 0, I get 0 plus 4, which is 4. At 1, I get negative 2 times 1 squared, which is just negative 2, plus 4 is 2, and so on. So if you plug all of these values in, you would get these points out. And those you can see plotted on our line here. Or not really line, but smooth curve, I should say. The vertex is at 0, 4. That's the high point of the parabola. The axis is again the y-axis, x equal to 0. Now let's look at another example. In example 3, we have y equals negative 1/3 x squared plus 4x minus 3. So now a is negative 1/3, b is 4, and c is negative 3. Again, when a is negative, the parabola is going to open downward. And because the magnitude of a, the absolute value of a, is less than 1, it's going to be wider than the y equal x squared parabola we saw first. When b is non-zero, this is going to move the axis of the parabola away from the y-axis. And for c, this is going to shift or move the parabola up or down. In this case, it'll move it down since c is negative. So I expect this to be a parabola which is wide, opens downward, and isn't symmetric about the y-axis in this case, and is shifted down 4 units. So here are a few points. If I plug in, for example, x equal to negative 1, I would get negative 1 squared, so that'll be 1. So that's negative 1/3 plus, and then 4 times negative 1 would be negative 4. So I've got negative 1/3 plus negative 4. So that's negative 4 1/3, and then minus 3, negative 7 1/3. Now if I plug 0 in, I would get 0 for the first two terms, and negative 3 for the second, and so on. If I plug in 6, what happens? I get 6 squared is 36, divided by 3 is 12, so I've got negative 12 plus 4 times 6 is 24. So negative 12 plus 24 is 12, and 12 minus 3 is 9. So 6, 9 is actually going to turn out to be the vertex of this parabola. So if we look at a graph, you can see that I've graphed the equation, I've labeled a few points on the parabola, and then I drew the x equal to 6 line because that is actually the axis for the parabola. That's the thing that if you folded the parabola across that line, it would be a mirror image of itself. Finally, I graphed all the equations on this one graph. So you can see the red is the last one we just did. The yellow one is the y equal x squared. That was the first one that we did. And then the black line, or the black parabola, okay, that's outlined in black there, that was the negative x squared, negative 2x squared plus 4 graph. So you can see how the red one is wider, the black one is narrower than this yellow, and then they're flipped upside down since they have a negative coefficient, either negative 2 or negative 1/3 in front of the x squared term. So that is how we begin with graphing parabolas and looking at just sort of the general characteristics based on what A, B, and C look like in terms of how they impact the location and direction of the parabola.